All right, welcome to our third example of solving systems of linear equations. If you watched the previous one, we're just going to take that one and modify it a little bit and see how we see something new. So let's go ahead and do that. Okay, so what we have here is the same system on the left as we had last time. Now before, we had zeros here on the right side, and that was the homogeneous case. So today what we're going to do is we're going to make it a little bit different. We're going to have what's called the inhomogeneous case, or not all zeros on the right-hand side. And so what I'd like to have over here are some numbers, and I've just chosen these here. So let me just fill these in. Let's see, 9, 7, and 7. Okay. So this is the inhomogeneous case. We've got some numbers here, and again, what are the possibilities? The possibilities are that this has a unique solution, an empty set as a solution set, or it could have an infinite number of solutions. Now last time with all zeros, we had an infinite number of solutions. So let's see what happens with these numbers here. So we're just going to do what we usually do, which is convert this into the augmented matrix. And it's going to be very similar to the previous examples, but we'll just go and fill these things in. So here's my augmented matrix. This part here on the left is exactly the same as it was before. The only part that really changes now are the numbers that we have on this side, on the right-hand side. Okay, so there's our system, and it shouldn't be too much of a surprise that we're just going to do very similar row operations that we did last time. A first thing we might want to do is take this first row and multiply it by -1 and then add it to the third row. So I did this before, but I'll just go ahead and do this again. -1, put that in parentheses, row 1 plus row 3 to create a new row 3. And I'm also, because it will make my life easier later, I'm going to take this first row and divide by 3, so I'm multiplying by a third. I'll do that after this other row operation. Okay, and if we do that, let me do this bottom row first. So just as we saw before, it's exactly the same, except the right-hand side is a little different. -1 times 3 added to 3 gives me 0. -1 times -3 gives me +3 added to -5 is -2. -1 times 3 added to -1 is -4. And we do have to worry about the right-hand side this time. So of course, -1 times 9 added to 7 is -2. And everything else is pretty much the same here in the second row. So we'll put that in. And this first row, this is where we're going to divide by 3. And we get that. Okay, so done a little work here, so now we're going to proceed with the next step. And of course, what we want to do next is we would like to make a 0 right here, and we can do that by taking -2 times row 1 and adding it to row 2 to create a new row 2. And so we'll do that next and put the result here. Okay, so let's just go ahead and do that. There's nothing that's going to happen to this row up here, so I'm just going to repeat it and just keep everything the same. Now let's take -2 times row 1, add it to row 2. That'll give me a 0 here. -2 times -1 is +2. Added to -1 is now +1. -2 times 1 is -2. Added to this guy, that's of course just 2. And -2 times 3, which is -6, added to this gives me a 1 right here. And I didn't do anything in this step to the third row, so that stays the same. Okay, so this is what we have. And now let's take it to the next page and complete the calculation just like before. So we'll just go ahead and do that. All right, so here we are on a clean page. Here's our augmented matrix rewritten for us. So now we'll just finish this off. So let's see what happens. At this stage, it makes sense to take the second row and create a 0 at where this -2 is. So I'll take +2 actually times row 1 and add it to row 3, and that will create a new row 3. and I will write the result down here. So these row operations preserve this column. So I'm not doing anything to the first row, so I'll just quickly write this down, and we'll see what happens. So we have 1, 2, 1 here, and now 2 times this row added to this one, the zeros stay the same. I'll get a 0 here. 2 times 2 is 4 added to this row, I get a 0. And now I have 2 times this row and added to this one, so it's 2 plus a negative 2, and that gives me a 0 here. And I see a row of zeros again, just like in the last example. But I will continue with what I'm doing. Just as in the last case, I can do a little more work here. I can zero out this position by taking row 2, adding it to row 3, and row 1, and creating a new row 1. And when I do that, I get the following. Let's see, I'll get a 1, 0, 0 here. That's not going to change anything. I'm not doing anything to the second and third rows, so those will stay the same. Zeros here. Whoops. That's actually a 1. Let's quickly fix that. Sometimes we have to do this. All right, that's really a 1. Okay, now I'll do this row operation. Okay, we just add these rows together, so 1 plus minus 1 is going to give me a 0 here. So I'll just write that there. And let's see, 2 plus 1 gives me 3, and 3 plus 1 gives me 4. And at this point, there's not anything else I can do. We have this row of zeros just like we did before. And so at this point, I realize I'm going to have a free variable because this x3 column does not contain a pivot. Only the x1 and x2 columns contain pivots. And so what I need to do is I need to write these now as equations and use those to solve. So let's see. So writing things down, I see that this first row turns into x1 plus 3x3 is equal to 4. And the second row turns into x2 plus 2x3 is equal to 1. Of course, what we do in this case is we always solve for the leading variables. x1 and x2 correspond to the pivots, so we solve for those guys. So at this point, we say that x1 is equal to 4 minus 3x3, and x2 is equal to 1 minus 2x3. So this is a little different than our last example. We have some numbers here, and we'll see how that makes a difference in a minute. So, well, let's go see how that is on a new page. So let me write those equations again because we're going to need them. x1 was equal to 4 minus 3x3. x2 was equal to 1 minus 2x3. x3 is itself, so the solution is going to be all the vectors that are of this form. x1, x2, x3, where x1 is given by this equation, 4 minus 3x3. x2 is 1 minus 2x3. I'm just substituting in here. x3 is itself. Okay. And just as I wrote before, x3 can be really any real number. Oops. That's just plain old r. So what we have here is that's our solution set. And I want to say a little bit more about this. We can see something interesting here. I can actually rewrite this a little bit, which I'm going to do. So I'll rewrite this set as follows. It is an infinite set, but I'm going to split it up. I don't really need to write this arbitrary vector up here. I'm just going to take this vector over here and I'm going to split it up. And what I'm going to do is I'm going to create two vectors, one which has x3's in it and the other which doesn't. So just using our properties of vectors, I can take this expression for this vector up here and rewrite it as the vector 4, 1, 0 plus x3, which I'll now factor out. And then I get minus 3, minus 2, 1. And again, x3 is allowed to be any real number. Okay, that's my solution set. And I wanted to rewrite it this way so that I could show you that, in fact, we get two pieces. This part here has no variable in it. The free variable doesn't appear. That's called a particular solution for this inhomogeneous problem. over here, if you've seen the previous example, you should recognize this. That's exactly what we had before, -3, -2, -1, the scalar multiples of that. This is the solution to the homogeneous problem. So this part of the solution will give you solutions when the right-hand side is just all zeros. And this particular vector over here, that is the vector that allows us to get to what we had originally, which is 9, 7, and 7. So this is another example of a case where we have a homogeneous system. Let's get back to our last page here. Here we have an infinite number of solutions, and our free variable figures prominently in that case. Okay, so next in our fourth example, we want to look at an actual case where there are no solutions. And so that's what we're going to do next. All right, until then, see you later.